So rocker arms we can use whether we have overhead valve or overhead cam. They come up in both applications. So basically any engine that's overhead valve is going to use rocker arms. That's what we're seeing here is an overhead cam engine. Overhead valve engine. So let's kind of go through the parts and pieces that get us up to this rocker arm. So down here in the block somewhere, we're going to have our camshaft, right? On top of our camshaft will be our lifter, whether it's flat tappet or roller. So we got our cam and then we have our lifter. From our lifter, we still got a lot of room before we get up to that rocker arm, right? So from our lifter, we go to our push rod. And that's what we're seeing here. So that push rod connects our lifter up to our rocker arm. So as the cam spins, we're going to push up on the lifter, push up on the push rod, but then our valve's over here on the other side, right? So to actually force this valve open, what do we need to do to it? We're going to have to push down on it, right? So the rocker arm is going to allow us to change direction. So as our cam, lifter, and push rod push up on this side of the rocker arm, we have a pivot point roughly in the middle, which means the other end of the rocker arm will get forced downwards, and that'll force our valve open. And so here's a typical rocker arm, very similar to what you see in the picture up there. So a push rod sits on one end, the other end of it sits right over the tip of our valve stem. One thing you'll see in this picture, and you can see on this rocker arm here as well, is that pivot point really isn't perfectly in the center, right? What that creates is what we call our rocker arm ratio. So they give you the math on this. You guys don't really have to worry about doing the calculations on this stuff. But based on the position of that pivot point, we create different rocker arm ratios. So let's say as an example, we have a rocker arm ratio of 1.5 to 1. That basically means the rocker arm is going to push the valve 1.5 times what the cam created. So we'll just stick with some easy numbers here. We'll say that our lobe lift on our cam was 1/2 inch, 500 thousandths. So that's how much the lobe itself would actually push up on the lifter and push up on the push rod. When we multiply that by 1.5, that's going to give us our true valve lift. So our valve would actually move, in this case, 750 thousandths. So the lobe can be smaller, but we still get a larger amount of valve lift at the end. So on most engines, they just have a certain rocker arm ratio. This is another thing that can be changed for performance use. So we won't worry about doing the math on it, but let's say we went to a 1.6 to 1 rocker arm ratio. Well, what's going to happen to our valve lift here? It's going to be bigger, right? So if we push that valve further open, we should be able to get more flow past it. Do we have to be concerned about piston to valve clearance though? Yeah. So here's another example of a rocker arm. So a couple different things we can see in this picture. Here's our push rod coming up, pushes on the rocker arm. Here's the pivot point here. Other end of the rocker arm pushes down on the valve. This rocker arm is made out of aluminum instead of stamped steel. So what would be the advantage there? Weight. Aluminum's lighter. So if that part's lighter, what happens to the amount of power it takes to move that part? A little bit less, right? So that frees up a little bit of horsepower. A couple other things that are different. This rocker arm pivots on basically a ball. So there's sort of a rounded ball this rocker arm pivots on. That reduces the friction. This rocker arm actually has a little needle bearing inside here. So by having an actual bearing inside there, this has even less friction to pivot back and forth. Less friction, that frees up a little bit more power as well, right? The other thing this one has, which you can't really see in this picture, is the tip of this rocker arm where it pushes on the valve. Rather than just being sort of nice and smooth, this actually has a little roller at the end. So as it pushes down on the valve, rather than sort of scraping across the valve as that angle changes, we have a little roller wheel that basically just rolls back and forth across the tip of the valve. So this is what we call a roller rocker. So if you've heard of an engine with roller rockers, that's what they've done there. And so these are very common in performance and racing use. So on this engine, overhead valve or overhead cam? Overhead cam, right? We have our cam up inside the cylinder head in blue there. So Now that we've moved our cam up to the head, we can get rid of some of those extra components. So in this case, our camshaft is directly driving our rocker arm, which then drives our valve. So basically in this application, we got rid of our lifter and we got rid of our push rod. So fewer parts and pieces, right? More power that we can make. On this one, you'll notice at the end of the rocker arms, we have adjustment screws. So this is what they call a mechanical or a solid valve train. So we do have to manually adjust that valve clearance or valve lash. And this is pretty much the exact same setup you guys had on that Honda engine that you guys did valve adjustment on. So one quick thing here in terms of terminology. Pretty easy to see why they call this a rocker arm, right? It looks just like the rocker arms we just looked at. So cam pushes on one side, has a pivot point, the other side pushes down on the valve. A lot of manufacturers in this sort of application, instead of calling it a rocker arm, they'll call it a camshaft follower. So essentially two different names for the same thing. Any questions on that setup at all? So we're just going to look real quickly at some of the different ways rocker arms are mounted, and this is all going to kind of go back to the overhead valve again. So this rocker arm is basically the same one that I have up here. This is what we call stud-mounted rocker arm. So there's a stud that sticks up out of the cylinder head. Rocker arm goes down. There's a little pivot ball that sits inside of it, and then there's a nut that holds it all in place. So that rocker arm basically rubs back and forth up against that pivot ball. So that's what creates sort of the low friction surface for it to actually pivot back and forth. Sometimes when that rocker arm gets bolted down, it's adjustable. Sometimes it's not, depending on the engine. Another thing to be aware of here. They have kind of a close-up view of the end of the rocker arm here, right? If you look at the end of that rocker arm closely compared to the one I have here, on that one, the end of the rocker arm has sort of a groove or a channel in it. This one's just perfectly smooth. Any ideas what that groove or that channel would do for us? Yeah, so that end sits over our valve stem tip, right? By having that groove or channel, it keeps the rocker arm on the tip of that valve. So it can't wobble off to one side or the other. So that's actually what keeps all that aligned. Some engines accomplish that a different way. So let me back up just a second. I'll show you another option. On this one, we said that this rocker arm has a little roller at the end of it, right? So if it has a little roller, that's not really doing anything to maintain that alignment, right? So that rocker arm can actually pivot back and forth. So to keep this one aligned, it's kind of hard to see in this picture because of the contrast, but around the push rod, there's a plate here, and they call it the push rod guide plate. So what that does is it keeps the push rod from wiggling back and forth. If the push rod can't wiggle back and forth, that means the rocker arm can't wiggle back and forth. So that's what's maintaining our alignment. So the push rod slides back and forth, or up and down in between that guide plate, but it can't wiggle side to side. So somewhere, somehow, we need to do something to maintain that alignment. So those are kind of our two common options, either the push rod guide plate or a rocker arm that has sort of a channel at the end. But something's got to locate those parts to keep them from wiggling around. So here's another example of that guide plate. So these rocker arms will be smooth at the end, so the guide plate keeps everything in alignment. And here's another option for how we can attach a rocker arm. This is what we call a pedestal mounted rocker arm. So a rocker arm sits down, we have this little pedestal. You can see it has kind of a half circle to the bottom of it, so that creates sort of that low friction pivot point. This one has a little oil deflector to help control oil flow to all this. And then this one's bolted down. So instead of using a stud with a nut, this style uses a bolt. And these are normally not adjustable. So it just gets torqued down and that's it. So we don't have any sort of valve lash adjustment.